Wow, we just started into routing and we're already into a topic of speaking binary. Now, I know some of you have gotten your feet wet in networking before and you know where this is going. You're thinking, if he's talking about binary now, that means subnetting is next. No! The most feared topic in all networking. But don't worry, you'll get it. And when you get it, you're going to feel like a ninja. It's one of those things that really pits all the pieces together of how these networks really work. And binary is a prerequisite skill for that. You have to get how computers and network devices really think. I was thinking about that "Walk Like an Egyptian" song, the Bangles. I was thinking like "Walk like a Cisco router." There's some kind of parody waiting to be written for that. So that's going to be. It's like you're thinking like the router when you're thinking of binary, and you're thinking like technology in general. Really, binary is just a 0 or a 1, an on or an off. You probably have heard stories of people that used to write computer programs on punch cards and feed punch cards into these machines, which just kind of have holes in them representing ons and offs and all that. And as fancy as our computers and technology are, really all we've done is gotten faster at processing zeros and ones, to where we can get all these fancy graphics and everything like that because our computers can just look at a bunch of zeros and ones really fast and put them all together, and that's why our graphics and everything else that we do are so sharp nowadays. So what we're going to do in here, review the basics of IP, kind of put us back into context. We'll look at Rico and Bob. I'll wait for that explanation till then. And then this nugget is really just looking at one major skill, converting from decimal to binary and back. Now, we can't just jump into binary without giving ourselves some network context first to really put us in a frame of mind. When we're talking about binary, we're talking about IP addressing and how we break up our networks to fit our organization. And right now, we are using IPv4. I'll talk about IPv6 in a little while, which is going to become a major player soon. But for now, IPv4 is where we're at. And I mean, we've seen these examples. We've got an IP address that looks like this: 10.10.10.1. Now, what we're looking at there is a 4-byte address. Each one of these being 1 byte. Now, you won't actually see, and by the way, that isn't why IPv4, I know everybody makes the link, they're like, oh, no. It's not where it got its name from, but you won't hear people talk about IP addresses in terms of bytes most of the time. You won't hear people say, oh, well, it's a 4-byte address, even though that is technically accurate, because when we're working in IP, we usually go down a level. You might remember early on in the series I showed you how computers deal with size, and I said, okay, we've got the byte, we've got the kilobyte, we've got the megabyte, and I was going larger and larger and larger, if I could talk and write. I was, getting bigger into the gigabyte, terabyte, blah, 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 blah. And I said, but that's not how we think about things in the network world. Everything in the network world is related to what? Bits, right? You remember that. So we go down a level to the bit, and it messes up the whole scheme because this is all 1,000, 1,000, 1,000, 1,024 or whatever. And so down here, we go to 8. There are 8 bits in a byte. So when you see the number 10 and you go, okay, that's 1 byte of data, you go, okay, well, really, it takes 8 bits to make that number 10. Okay, what's that mean? Well, what is a bit? A bit, I start off on the objectives, is an on or an off. A 0 or a 1. So when I look at the number 10, I go, okay, there's actually 8 zeros and ones that are necessary to create it. It's actually that. And by the time you're done with this nugget, you'll be able to do that too. You'll be able to look at numbers and just go, okay, I kind of see. Now 10 is a very simple number, which is why I could look at it and do that. But you'll be able to at least work it out and figure out how did I get this number from the number 10. Now, okay, great, Jeremy. So why is this relevant at all? Well, because in the network world, we don't work in terms of nice, clean boundaries. Like we have so far in this series worked with what I would call classful subnets. Meaning, we're sticking to the original classes that were created back in the 1960s when whoever you are convinced that created it, created the IP protocol and developed that technology. They said, okay, well, there's going to be a class A, B, and C address, and we're going to have a subnet mask of 255.0.0. You remember this? 255.0.0.0. So class B, 255, 255. Come on, it's coming back to you, right? So we've got all these different classes of addresses that were created originally, and that's kind of what we stick to. And we say, okay, well, these are the nice clean boundaries. So when we take an IP address and combine it with a subnet mask, it gives us what portion of the IP address is the network and which portion is the host. So let's take this. If I combine that with a class A subnet mask, if I take 10.10.10.1 and I say, okay, subnet mask 255.0.0.0, right? Then I'm able to look at that and go, okay, well, actually 10 represents the what? Network, right? And all of this other stuff represents what host you are on that network. So that's a lot of hosts. When you realize each one of these values can go to 255, it actually comes out to 16,777,214 hosts on one network, which is insane. You can't have 16 million hosts on one network. It's just too big. That means one broadcast from one of those hosts will go to 16 million buddies. They're all sitting there connected to the same network. It doesn't scale. I mean, rough numbers. I mean, somewhere around, I would say at absolute most, 500 devices or so. Now that's, I'll say I've seen that recommended from Cisco, but there's no document I can point to say that's it. But I mean, somewhere around 500 devices, that's about as big of a network as you want before, broadcasts are starting to get a little crazy. So 16 million, not even the ballpark. So what we do is we say, well, if we can't do that, then let's take I gotta go back to purple. I can't stay red. Let's take that 10.10.10.1 and line it up to a class B subnet mask, right? See what I'm doing here? I'm saying, okay, well, I want to take that bar and move it over, so this now represents the network, and this represents the host, which makes it a little more reasonable. I go, okay, well, that's good. It's not 16 million hosts. Well, if you actually total it up, that's 65,536? Maybe 4? I can't. Come on. I can't remember all the numbers, but I'll say it's 65,530 something IP addresses that are all on the same network. I think 36 that are total and 34 is usable, but we'll go with it. I digress. So still way too big. And that's why you see these Class C subnet masks getting thrown everywhere. It's essentially lazy subnetting, to where somebody takes an address like this, which is technically a Class A address. Again, more on that in a little while. And start putting Class C subnet masks all over the place. 255, 255, 255.0. So what that does is say, okay, this represents the network. All the computers on that network have to start with 10.10.10. And then this last one represents the host that you are on there. And that gives you 254 usable, 256 total addresses, but 254 usable addresses, because you can't use the very first or the last IP address of each range. Again, more on that as we expand into subnetting. I just want to give you the context here. So these are big jumps. I mean, to move from 254 to 65,000, I mean, come on. Isn't there something in the middle? I mean, can't I say, well, can I move to I don't know, 500-ish or 1,000-ish addresses on a network? And the answer is yes, you can. Yes, you can make those kind of jumps, but in order to do it, you have to know binary. You have to know that when you see a subnet mask of 255.255.0.0, you're looking at it in what's friendly to us as human beings, a decimal number. But behind the scenes, there's actually a binary number that lines up to it. Matter of fact, 255 is 111111111. 8 ones that go inside of that make that number. And what I can do is say, well, instead of just trying to change the decimal, and trying to make that make sense, I have to work with the binary behind the scenes, because that's where it really goes, oh, that makes sense. And that's how the routers deal with it. So these IP addresses all operate at layer 3. So again, we are in the routing section now. We have left switching behind for the time being. So layer 2 devices, MAC addresses, all that's back there. We're now moving to routers, which are getting us off of our networks. I mean, the switches and the layer 2 devices, these guys are good for local connectivity, like I want to talk to the computer down the hallway. But when I'm talking to the internet, or I'm talking to a server not on my network, that's where I need layer 3 connectivity. That's where the routers come in. So think of that last slide as kind of a review of where we've been, and at the same time a sneak peek of where we're going. I know there's some pieces that don't quite fit, but they will. That's what subnetting is going to put together. how do you even transition from that into? I mean, you're looking at this. How do I transition into Rico and Bob? I don't know. So I'll start off by saying yes, I did draw that myself. Yes, it took longer than I would like to admit to draw something like that. But here we go. Rico and Bob are really kind of a tale that puts the subnetting or binary pieces together. So Rico is a brilliant scientist who has invented a construction brick that is both lightweight and very sturdy. And I'll add in another one, and inexpensive. So, construction bricks are typically concrete. You throw them on the ground, they smash in a million pieces. So he's created this brilliant brick for construction. And so, a brilliant scientist, not much of a businessman, he took all of these bricks that he's manufactured and just put them into a big old pile in a warehouse. And he hired Bob, his sidekick, his handy assistant, to help him. So our first construction guy comes up and he's like, "Hey, Rico, I heard you about this brick. I want 210 bricks." So Rico turns around and goes, "Hey, Bob, 210 bricks." Bob goes, "Okay." Runs to the side of the warehouse, brings a brick to the front. Here you go. Okay, one brick. Runs back to the warehouse. Two brick. Brings it back up. Here you go, Rico. And so this is sweat. Do you feel it? It's pouring off of him. He's in the air, levitating right now. He's jumping from one to. He's trying to move so fast, and he just can't keep up. And so do you see the concern? Again, I took some time here. The concern on this man's face. He's like, wow, 210 bricks. I'm concerned. I want 120 bricks, and this is going to take forever. But I'm not angry because I'm going to get my bricks eventually. But this little man. Not only is the shortest man in the line causing frustration right there, but also 15 bricks is all he wants, but he has to wait for these other two. So you feel the anger on him. So somewhere around brick 63, Bob collapses. He's like, "Rico, close the door!" Chung, it's like in the mall, ching 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 ching. Those little metal things. So Rico's like, "Okay, Bob, you all right?" And Bob's like, "We can't do it. We can't run the business like this." And so he's like, "We've got to come up with a new system." And Bob, while Rico's the brilliant scientist, Bob, brilliant kind of organizer, if you will. So he stands up, he goes, No. He's like, we need to get pallets. He said, "I'm going to make a pallet of 128 bricks." This is where my art falls apart. So a pallet of 128 bricks. I'm going to make a second pallet of 64 bricks. A third pallet of 32 bricks. And we got these bricks that are sitting on there. A fourth pallet of 16 bricks. A fifth pallet. We're kind of not really needing the pallet at this point, but hey, why not? A little bundle of 8 bricks. We'll take a pallet of 4 bricks, and then a pallet of 2, and then just the single brick pile. So we've got all of these bricks. So he kind of takes this pile and organizes in all these pallets. He goes and buys himself a forklift with their newfound fortune in selling these bricks. And so Rico ching 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 lifts the gate back up. Hey, I got to delete that. It's taking away from the reality here. So lifts the gate back up, and the guy's still standing there a day later going, "I still need my 210 bricks." And so Rico, now equipped with flags from Bob's handy store idea, Rico just walks around and puts flags into the piles that need it. So Rico goes, "Okay, 210 bricks, so I'm going to put a flag in the 128 pile. It's the most efficient to take the biggest first, right?" So 210 minus 128, let's see, there's 1, 0, there'll be 2, 1, 8. By the way, stop the story train right there. Cisco exams, no calculator, my friend. So yes, you will have to practice some math skills beforehand. And now, of course, as I'm recording this, I've got to say, in teaching IC&D, I've made plenty of my own mathematical errors. So if I make one, I'm sure I'll review this later and find it. So 82. So we still have more. So let's put a flag in the 64 bricks. So that'd be 8, 7, 2, 8. That'd be 18 left over. Okay, no 32s. Okay, 16. Got to put a flag in there, right? Are you getting how this is going? So, okay, 2 bricks, no 8, no 4, no... Oh, we got a 2. Flag in the 2. Minus 2. 0. Done. Order fulfilled. Okay, Bob, do your thing. Bob has his forklift. He wheels these out, and customer A is satisfied. Right. So what this is actually how binary works for numbers, how a computer applies binary to numbers behind the scenes. Now keep in mind, when you're talking about, let's just talk a computer or a router or anything, it's doing everything in binary. I mean, you move your mouse and binary things are happening behind the scenes. You open Internet Explorer or Chrome or Firefox and binary things are happening behind the scenes. It's always doing that. So there's ways there's ways to apply numbers or binary to all kinds of things. I can apply binary to pixels on a monitor and what color they are, how large they are, how many of them there are. So you can apply binary to operations on a computer, like saving a file to the hard drive. Where's that file stored? How's that file written? All those kind of things. So I'm just talking about one application of binary. When a computer processes numbers, this is what's happening behind the scenes. Wherever you see a flag in this actually represents on or 1. Wherever you don't see a flag, it represents a 0. So using 8 bits, this is how we would process numbers, we'll say 0 through 255. So the number 210, in actuality, the way a computer sees it, is 110101010. We see 210. Computer sees 11010010. That's 8 bits, 8 binary numbers. Okay, let's try another. Okay, so next customer B comes up and says, okay, I want 120 bricks. Okay, now Rico's got his flags in order, and I guess didn't think about flag removal. So we'll just grab these guys. Okay, there we go. Oh, man, I'm just taking out piles left and right. So you guys get the concept, right? So, okay, there really was no pallets or piles of bricks. It's just an analogy, but it works. Okay, so I'm going to have let's do 120. No flag in 128. Okay, flag in 64. So let's subtract 64, 1, that'd be 6, 1, that'd be 0, 11, 5, 56 left over, right? 32, 32 minus 4, 2, 24. Okay, 16. Is all lining up. So 16, that'd be 2, 1, 14 minus 6, 8, right? Yep. So 8 left over, flag right there, 8 equals 0. So all the rest goes 0. So when we come to 120, this in binary is actually 0. We don't take off the leading zeros because we are really kind of in a fixed, at least with IP version 4, every octet is 8 bits. So we're stuck with these 8 bits. So we're going to go 0, 1, 1, 1, 1, 0, 0, 0. Is that right? That's 8 bits, right? So that's our 8 bits that put those together. Okay, so we see 120. Computers, routers, everything else sees 0, 1, 1, 1, 1, 0, 0, 0. Now, before we figure out the short angry man and his 15 bricks, I want to go back to the values themselves, because I know some of you more analytical people might be thinking, well, okay, I'm seeing how this works. I get the system, but where did these numbers come from? Like, why did they get 64 or 16? I mean, I kind of see, I multiply by 2 to get them, right? Well, yes. When the powers that be figured out how devices process numbers, they said, well, what we'll do is we'll make the binary values represent powers of 2. So 2 to the power of 0 is actually 1. Anything to the power of 0 is 1. And I don't know exactly why that is. I know anything times 0 is 0, but anything to the power of 0 is really 1. So we move over and we go, okay, well, the next one is actually 2 to the power of 1. So 1, 2. So we go to the next one. We have 2 2's. 2 to the power of 2. 2 times 2 is 4. 2 to the power of 3 is the number 8. Now, it'll be good. I'm showing this to you because it'll be good for you to know this when we get into some of the more advanced subnetting. Knowing that these are just powers of 2 will kind of give you a shortcut in some cases. So really, if we're trying to generate these, frankly, I never remember. If I look at 128, I don't think 2 to the power of 7. That doesn't pop into my head right away. If I forget these numbers, I just say, okay, we'll start from 1 and just multiply by 2. 1 times 2 is 2, times 2 is 4, times 2 is 8, times 2. I mean, and come back and fill in the powers of 2 a little bit later. But I just want to show you behind the scenes, that's how the computer actually does it. So let's look at Angry Man 15 bricks. I want my 15. I'll look up here. I'll just keep the flags there so for time's sake. So I'm going to say 15. Let's go. No 128s, no 64s, no 32s, no 16. So all these are zeros to start off. 1 8. So 15 minus 8, that leaves you with 7, right? So 1 4, that leaves you with 4. So you notice I always start from the left to right. I'm always trying to take the biggest value from something. So I've got 3, so that's 1 1. 2 and a 1 equals 3. So I'm always going to get to 0 at the very end. So 15 as a binary value is 0 0 0 0 1 1 1 1. Okay. So these skills that we're going through, binary, subnetting, they're all skills that you can watch somebody do and go, oh, okay, I get that. But until you do it for yourself, it won't actually stick with you. When it comes time to do it, you're like, oh, now how did that go? So for these next sections, I'm going to have some homework for you, stuff to work on your own, so you're able to master the skill. So here's what I'd like you to do. Pause this nugget right now. After I finish talking, pause this nugget and work through these 5. If you don't get number 5, that's okay. That's my challenge question. Work through these 5 and see if you can get them, and then unpause, and I'll work through them with you. Okay? So pause now. Okay, welcome back. So we've got 180 to binary. Let's look at that. Whenever you do these, it's all. I mean, you got to give yourself the grid to work from. Write those values on the piece of paper or whatever you're working with. So I've got 128, 64, 32, 16, 8, 4, 2, 1. If you need to write them right to left, you multiply by 2. That's fine until you master them. But trust me, you will get these numbers down. You will remember them. So let's look at 180 to binary. What we do is always start with the biggest value. So 180 minus, and I'll go, okay, 128. I can subtract 128 from there. 128. That equals 7, 252 left over. Okay, can't take a 64, so I'm going to write a 0 there. 32, yes, so I'll put 32 minus equals 20. 16, I can take 16 from 20. 16 minus equals 4. So no way, it's definitely 1 4 0 0. I can just fill those in because 4 is going to zero us out. So 180 in binary is actually 1 0 1 1 0 1 0 0. Did you get it? Cool. This is my first time actually using this eraser on my pen. It's pretty cool. Okay, so I've got 180 now. Okay, let's look at 41. So 41 in binary, I can immediately say, okay, no, too big. 132, let's subtract that. That'd be 9 left over, so no, yes, and no, yes. So 41 is 0 0 1 0 1 0 0 1. All right, good. Now, I kind of flipped the game on you as while we're talking. I haven't given you an example of this yet. I just want to see if you could kind of reason through it and say, okay, if somebody gave me a binary number, can I convert that back to decimal? How would I do that? Well, really, you just line it up. It's it's a little more math than subtraction, but I say, okay, well, let's line it up to the binary or the decimal values above. 1 1 0, and then just do some addition. So I'll go, okay, 32, really it's 32 plus 16 plus 4 plus 2 will give me my decimal number. So let's start here. Let's go 8 and 48, right? And then add 8 in there. So, wait, no. It's so easy to make a mistake when I'm talking. So add 6 in there, right? 4 plus 2. So we've got 54. So 0 0 1 1 0 1 1 0. What am I doing? No, the decimal value of that binary number is 54, right? So that's the decimal value. Okay, next one. 1 0 0. Sorry, my cell phone. I have it on buzz mode. And it goes bzz behind the scenes, and immediately my brain is like, what's that? What's that? What's that? And so I stopped thinking. Okay, so 1 0 0 1. Where are we? 0 1 1 0. Okay, so adding those up, so I've got 128. Now I always look around for easy math because I'm not the greatest at it. So I go, okay, well 16 plus 4, that's 20, right? So 20 plus 128, that'd be 148. Plus 2, that's 150. So you can jump around like that. I mean, you don't have to add them in order. You're adding, it doesn't matter. what order you're going in. So I always try to find the nice even values that go in increments of 10 for people like me. Okay, so that will be that one in decimal. Okay, now let's look at the challenge question, right? I already saw this off there. Challenge question says convert 650 into binary. Now, the challenge about this is we haven't seen anything like it because with these values that are on the board right now, I can't get any higher than 255. With 8 bits, I can't go higher than that. So to get 650, I actually have to go beyond 8 binary bits. It's that simple. So what I do is I say, okay, well, let's multiply by 2. If I multiplied 128 by 2, I get 256. I multiply 256 by 2, I get 512. You might be saying, how are you doing? I've just seen these values so often that you just get used to them. But if you need to, write up a quick multiplication question, it's no problem. So if I multiply, I still look, I'm okay, 512 is smaller than 650, so I multiply that by 2 and I get 1024. Now be careful. Be careful, because when you're looking, you go, okay, 1024 is bigger, so that's what I put a 1 by, right? No, remember, we always subtract whatever we can subtract. I can't subtract 1024 from 650 without getting a negative number. So essentially, I look at that and go, okay, that's too big. That's not gonna do anything for us. So I'll look at 512 and say, okay, that's the first value that I can subtract. So 650 minus 512 gives me, that'd be 6. Well, actually, let me 5, 4. That'd be 10, 8. So 3. 1, right? Because I shouldn't have marked through the... Is that right? 138. Yeah. Okay. So 138. 256. Nope. Can't take that away. Okay. 128. That's good because that gives me a nice small value to work with. So I go down to 10. I go, okay, great. 0, 0, 0, 1, 0, 1, 0. Right? So 8 and 2 is that 10 that I'm looking for. So that gives me 0. So really, the binary value of 650 is 1, 0, 1, 0, 0, 0, 1, 0, 1, 0. Good. So we went beyond the normal 8 bits that we're used to seeing with IP version 4. Now you might look at that and go, okay, well, will I do a lot of that? Some. You'll do some. I'll explain situations where you'll do that when we get into the more advanced subnetting. But I would say by far, in IP, you're going to be sticking to 8 bits. You're going to be sticking to those values. So I would say think of going beyond that as more of an exception, like you don't do it all the time. And the bulk, the lion's share of what you do just sticks to that 8-bit boundary. Okay. You have just taken a step into IP subnetting. You've learned the foundational skill that you need for everything IP subnetting that's going to be coming up. That's a huge step. What would I suggest you do with it? Practice. Do not go into the next nugget until you do some more practice. I gave you 5 questions, but that's not enough. I would suggest that you grab a piece of paper, just a white sheet of paper, and do 10 more decimal to binary. So write down just 10 numbers. I would suggest keeping them 255 or less, and then convert them over to binary to make sure that you have that. And then once you're done with that, do 5 more questions on binary back to decimal. And do that conversion to where it becomes one of those things that you get really familiar with, and it's starting to feel comfortable for you to do those kind of conversions. Now you can actually check your work. If you open the Windows calculator, just do Start, Run, Calc, or I always hold down the Windows key and do R to bring up the run, and so you just type in Calc right there, or you can find it somewhere in the Start menu. I think it's under Accessories. Now I have mine in the Programmer view. By default, most of the time it'll come up like this if you haven't done this before. In Windows XP or earlier, if you are earlier, you want Scientific View. In Windows 7 or 8 or wherever you're at, jump over to Programmer View. Excuse me. What you want is this decimal binary selector. So that way you can always come in here and say, I want the number 89, and click on binary, and it says, well, here's the binary value for that. Or what is 11? What is that value? In decimal. Click that, and poof, it'll tell you what the decimal version of that is. Now keep in mind, like if I do 56 and I shoot back to binary, this does drop the leading zeros. So it shows in this case 6 bits. So in the number 56, there's no 128s, there's no 64s. The first one is a 32. So don't let that throw you off, because the calculator does drop the leading zeros when converting to binary. Now, second thing I want to say right now is some of you are probably looking going, Wow. So you're saying this could have been a 5-minute nugget on how to use Windows Calculator to convert to binary. Why do I have to know this if I can use a calculator? Well, number one, on the exam, I've already told you there is no calculator, so you have to know it if you plan on getting certified. But number two, this is a skill that is foundation to networking. Like this, you cannot really master networking without knowing subnetting, without being able to do that. And I can't tell you how valuable it is to have that skill, because there's some people. I mean, I just showed you a binary calculator. There are complete subnet calculators out there too that you can just type in values and it'll tell you all the subnets that you need and all that. But let me put it this way. If you talk to somebody who does Cisco or does networking as kind of a peripheral of their primary job function, like their main thing is I work in Microsoft or I'm a programmer and I can do some Cisco as well. For those people, most of the time they will say, yeah, subnetting, I use a subnet calculator. Probably just because they don't deal with it enough to really solidify the concept in their mind. However, if you talk to somebody who does Cisco, who does networking, like this is my job, this is what I do. I work for a service provider. I work in data centers regularly. I work for a Fortune 500 company that's large enough to have a full-time network person or multiple full-time. I mean, if you ask those people, can you do binary, without a calculator? Yes. Can you do subnetting? Yes. You'll be able to. I can't tell you how valuable it is. I mean, there's so often I've been in a network environment. It's just I'm smiling because just this last weekend I was actually at a data center and we were trying to figure out, and the data center said, okay, we're going to be dropping your connection on 2/30 subnets. So it'll be the network ID is I can't remember 185.0.9 or so they're rattling off the network ID, and the guy I was with, he goes, all right, subnet whiz. What is it? And I go, okay, we need to assign 9 over here. We need to assign 22, to where you can just kind of think through it and process it, without having to, okay, I'm not too sure. Let's boot up my laptop. Let's get, it's just skills that you use all the time. So, run through that practice. Make sure you've got the binary conversion solid, then jump into the subnetting. I hope this has been informative for you, and I'd like to thank you for viewing.